Okay, now we want to talk about molecular polarity. So carbon tetrachloride, so CCl4. You know the shade, so the central atom is CCl, here, 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 and here. Since the carbon has a partial positive charge, why? Because it's less electronegative. And Cl getting partial negative charge. Partial negative charges here. Show that with the sigma. So what I do, I show the arrows from positive to negative. So this is the arrows, the direction of the electronegativity. Here is up, here is down. As you see, this arrow is in opposite direction. They cancel each other. So these two cancel and these two cancel. Therefore, I know that each bound is polar. How do I know the polar? Just find the difference between the electronegativity of the CSCl. If this is the greater than 0.4, we say that this bound is polar. It is polar, but since the molecule is symmetry, these vectors cancel each other, so this is non-polar molecule. Non-polar molecule. Now look at the O3. O3 is a polar molecule. The reason is that we have this oxygen here, having 6 valence electron. I make another oxygen here with the 6 valence, so because this is O3 means 3 oxygen. I make another oxygen here with 6 valence electron. So this lone electron will come and make a bond here. This lone electron make a bond come here. What happened? This electron will move here. When this moves here, we have no electron there. Oh, wait, just erase the whole thing. We have no electron in this area, so this will come and share. This empty space will suitable to share these 2 electrons. So this is going to be one single bond. That's why we have a single bond with oxygen, double bond with another oxygen. Make sure, see, this is the 2 lone pair, as you see, 2 lone pair here, and 3 lone pair, 3 lone pair. Okay, anyway. Since this one is kind of giving all of these electrons to this one, so it's going to be positive, partially positive will be there. And this become just attracts so many electrons around it, so it's partial negative. And that's why it's, so between these two, this is again gonna be partial negative. As you see, the direction of the vectors from positive to negative. These 2 vectors are not in opposite direction. They don't cancel each other because we have this lone pairs here. It is kind of, this bound is, look at here, it's just has an angle. Why? Because this lone pair will push away these 2 bounds, so it's make them to have an angle. Okay, so therefore this is polar. So here is NH3. NH3 and have, of course, 5 electron, hydrogen, 1 electron. Everyone knows the shape. Shape is pyramidal. And this will be more electronic. It's going to be partial negative. Here is partial positive. So make sure you just show the bounds. Partial positive, partial positive, partial positive. If you want to show the direction of the vector, so this is the direction of the vectors. These vectors will not cancel each other again because of this lone pairs here is not symmetric. So this is polar. Okay, look at COH4. Actually, CH3OH, methanol. Since we know there is a partial negative here, here is partial positive. That would be a vector here from positive to negative. So why I'm not talking about CH? Because CH and CH is, they don't make a polar bond. Just C and O make a polar bond because the difference between the electronegativity is greater than 0.4. Here again, we have a partial negative, partial positive between O and H from positive to negative. These two vectors will not cancel each other, so this will be polar. So the polarity gonna be on this end. The same thing, see, we have an OH bound, again, the same reason this is gonna be polar, this is gonna be polar bound, this is gonna be polar. So since we have a polar ends, the total molecule here is polar. So that's it for molecular polarity.